Hey guys, so now we are almost at the end of our chapter. We have looked at what water of crystallization is through an activity. Today we'll be talking about two salts that have this water of crystallization within them. So the first salt we are going to talk about is called as washing soda. Okay, it's different from baking soda. It's called washing soda. To get to washing soda, we need baking soda first, right? So we know that baking soda is NaHCO3 or sodium bicarbonate. So whenever this sodium bicarbonate is heated, that is how we use it, right? We heat it. So when you heat it, it forms three different compounds. It will form sodium carbonate, Na2CO3 plus H2O, which is water, plus CO2, right? That is the CO2 gas that makes our cakes fluffy, right? That's what we studied. So now, apart from the CO2 and H2O, there is Na2CO3, right? Sodium carbonate. We use this sodium carbonate to bring us washing soda. So for this, if I take the sodium carbonate and add 10 parts of water, okay, that will give me sodium carbonate dot 10H2O. So the equation will be Na2CO3 plus 10H2O gives Na2CO3 dot 10H2O. Now we know this dot means this is the water of crystallization, right? So now I can tell that for every 1 molecule of sodium carbonate, there are 10 molecules of water attached around it. Okay. So just imagine it as like one sphere in the center and then like 10 dots around it. That is what washing soda is. Now this washing soda is very useful in many processes. Mainly it's in the name, washing, right? So it's used as a cleaner. It's used in many cleaning products that we use at home. Sometimes it could be in your detergent, it could be in any other cleaning appliance like Colin or anything, right? Another use for it is in industries, okay, like glass, soap, paper. There are a couple of industries that use this chemical to do some process or the other for making what they are supposed to make. Now another use for this is in making something that we call borax. Okay, so borax is a powder. It's a white colored powder. Sometimes you get this if any of you have played carom board. You get this powder that you put on the carom board specifically just to make the carom smooth, and it's called boric powder or borax. It's pretty much the same thing. So this sodium carbonate can be used to make borax also. Finally, one more use is to remove what we call as hardness of water. If you remember, you must have studied about hard water and soft water very long ago, right? A hard water is nothing but water that has some or the other salts dissolved in it that make it difficult to use. So if you add soap to that water, you won't get foam, right? That is called hard water. Mostly cities have this problem where we get hard water. Now if you want to make this hard water into soft water, to remove all the salts, we can use this washing soda. Okay, it changes the hard water into soft water. The next salt we'll talk about is plaster of Paris. Okay, now this is a salt that some of you might be familiar with, Okay, so there is a compound called as gypsum. Okay, GYPSUM, gypsum. The formula for gypsum is calcium sulfate dot 2H2O. Okay, CaSO4 dot 2H2O. So gypsum also has water of crystallization. For one molecule of calcium sulfate, there are two molecules of water. Okay, if I take this gypsum and I slowly heat it, right, I'm going to make it hotter. So whenever we heat, we notice that this water of crystallization will go away, it will start leaving. Okay, at one point this salt becomes something called as plaster of Paris. Okay, the chemical name for plaster of Paris is calcium sulfate hemihydrate. Okay, so the formula for it is CaSO4 dot half H2O. Okay, so it reduced from 2H2O down to half H2O. Okay, one thing you might ask, how can one calcium sulfate be attached to half a molecule? How do you make half of a molecule? You cannot, right? You cannot break a molecule clean into half. That doesn't work like that. So when they say half H2O, what they're saying is two molecules of calcium sulfate are attached to one molecule of water. Okay, so imagine two big calcium sulfate, right? In between them one small water molecule. It's kind of attached to both. So since one is attached to two, we say half, right? That is why we say half H2O. All right, so as simple as that. This is called as plaster of Paris. If I have to talk about the equation, it is simple. Calcium sulfate on heating, gypsum on heating gives me plaster of Paris. Okay, if I use this, right, if I use this plaster of Paris, where do I use it? Two major uses I can tell you. One, if you ever had a fracture or know anyone who has, that doctor ties one white colored cast around their leg. That is nothing but this plaster of Paris. Okay, so what they do is you'll get like sheets of plaster of Paris. Okay, once you add water to this plaster of Paris, it will change back into gypsum. Okay, so what they do, they wet that plaster of Paris, wrap it around your leg. Once it gets time to dry, it becomes gypsum. It absorbs the water and gypsum becomes like, it's a very hard substance. Okay, so that is how plaster of Paris is used, to make it back into gypsum. So that is one major use of plaster of Paris. Another use for this is, if you see in buildings, there is some sort of interior decoration that happens, right? False ceilings and some deco. All of these things also use this plaster of Paris. So it works in the same way. You just use it, wet it, and you solidify. It becomes hard and it becomes your whole interior. It's also used in making toys or things like that. And if you also have seen wall putty, right, you put that before painting the wall. Yes, part of that is also gypsum. So once you add this and you just make it flat, it becomes perfectly smooth, right? So that is another simple use for gypsum or plaster of Paris. Okay, so to recall, we have studied two molecules today, or two salts: washing soda, plaster of Paris. Washing soda is sodium carbonate with 10 molecules of water, right? And plaster of Paris is calcium sulfate with half a molecule of water, right? The half means it's shared one molecule of water between two calcium sulfate molecules. Okay, so that's about it. These are the last two salts in your syllabus. After this, we are done. and tomorrow you'll be having your assessment for the end of the chapter. So do prepare from your notes. Tomorrow is going to be a big assessment. Okay, thank you.